an activation function which will give you the value between 0 to 1, and that will be the value of this node. So just to say it in simpler, first you assign a value to randomly to all the weights, then you do a summation function, and then you uh, have an activation function which will determine the value of this node. Similarly, you will do for all the nodes and calculate a value of this hidden network. And now this will become an input for the next layer of hidden network. So similarly, you will assign random weights to each of the network. It's difficult. And that's how you move forward and ultimately reach a value to the output node. If it is supervised learning, let's say, for example, you're determining whether based on the input it's a cat or a dog, and you assign value 0 for cat and 1 for dog. Based on those random function, let's say you got a value of 0.75 instead of value of 0, which is actual value. So that is an error which you got. And the way the algorithm works is, first you initiate all the weights, you calculate all the values in that layered network. Once you complete the first round and evaluate everything, it's called a forward pass. And you decide different types of hidden layers based on your intent or objective. So for example, if I am operating on images, the type of hidden layer network I would use is convolutional layer. If it's a time series data, let's say of some energy analysis and per hour data, I would use recurrent. So depending on your data, you will select a type of hidden layer network. So these are layers. How to quickly erase. Right, let's move. So once we know the layer of the whole artificial neural network, as I mentioned earlier, now you know the value which is computed by the network. Let's say it's 0.75, but the actual value, you know, based on your label item, it should be 0. So the difference between this is an error or a loss. So basically all we are trying to do and what we are aiming to train the network is to calculate all the weights in such a way that we minimize this error. So our objective is to have to perform an objective function and optimization algorithm which can update the weights of each of the connection so that we reach as close value to the labeled output. Mm, all right. One of the optimization algorithm which is commonly used is SGD, stochastic gradient descent, and it basically uses a backpropagation technique, which means you perform a derivative function with respect to each weight and you go backwards. So that's in short is a backpropagation technique. And one of uh, the commonly used function for to calculate loss is mean square error. So to summarize, first we define layers, we The computer generates random values to those connections. We calculate the value at the output node. Then we compute what's the error or loss function. Then the next step is to calculate the gradient to minimize the loss function. And that's how multiple iterations, each of these weights are continuously updated. And as you can see, just like for this eight eight input node, there are so many connections inside this. So if let's say we have a 524 by 524 images, there's so many pixels. So there are several of those connections which we need to do an optimization program. So that's why when you hear like it takes a long time to train a machine learning algorithm, it's because there are so many weights that they need to optimize to to train that model. So this is how a training in an artificial neural network works. Then you may think that this is all about optimization, then what is the difference between normal mathematical optimization and artificial neural network optimization? A few, I found like two main differences. First is the metrics. Generally, in a optimization problem, you know uh, a function and which is differentiable. And in artificial neural network problem, depending on the type of learning, which I'll discuss soon, there might be some functions which are not differentiable. So that's why a common optimization algorithm approach doesn't work for it. And the way we work around is we find a similar uh, an, uh, an alternative function in which we can differentiate it and draw an analogy. Second is the data. I think it might be better if I open this link. Yeah. So as I discussed earlier, the first difference is the metric function. In normal case, we have single well-defined objective, but in deep learning, it's very hard to optimize on. And these are not like sometimes it's not differentiable. So we use proxy metrics to work around that situation. Second is the data. In normal optimization, we have a definite data in hand which we need to work around. But in deep learning, we are we care about generalizing the data which we don't have. Especially, it's very you can think about it in terms of GAN. In GAN, based on the training data, we are generating new images which are not part of data, and it should match so that we can fool the discriminator and it generates realistic images. So these are the two major differences why uh, we use this type of network versus a conventional optimization. Okay, let's move ahead. All right, how a learning in an artificial neural network works. So I discussed about a forward pass. In the way we do is we define a, a batch. Let's say we have 1,000 data sets, and if we define a batch of 10, it takes 100 passes so that one whole data set operation is done during the training. And after one single pass, I'll show you later how about a StyleGAN training I did in Collab, and you will see the epochs information from there. Next is, yeah, gradient of loss function, which I discussed earlier, that we computed using backpropagation. And one thing is, you also need to determine the learning rate, which is generally between 0.01 to 0.001. So after you perform this loss function, you update the weights, and this is the formula: new weight equal to old weight minus learning rate into gradient. All right, so what are the different types of learning? One is supervised learning, where we know the input data and we also have a label associated with data. One example is, if I am making a model of classifying cats and dogs, out of all the training data, I know which images are cats and I know which images are dogs, and I can assign a label, let's say 0 to all the cats images and 1 to all dogs images. So that's how uh, I can create a supervised learning model, and it will generally will come in terms of numeric value. So we can train all the input data, and after training, then when we have a new image input to that whole train model, it can, if it's a cat, it will do the operations, and at the output it may suggest this image is zero point zero 0.02 value, which means it has this much probability of being a cat. And if it's highly probable that it's a cat, then that's how the model is trained. It can determine based on all the training. Second is unsupervised learning, where we know the data, but the set is not labeled. So GAN is a type of unsupervised learning, where in yesterday's example, we had the data of all the Indian architecture temples, but we didn't label it that individually. And the intent was we create a style from it. A few examples which you can look later is clustering algorithms and auto encoders. And you might think, okay, what's the use of this kind of unsupervised learning if it's just creating a, realistic images from the trained model? So one application you may think of is denoising. So let's say there are images which you train on. Let's say you train on a lot of images with buildings in it, and now once the network is trained, if you input an image with additional noise, let's say it can be temple or people, then the machine learning algorithm will be able to determine that people and those trees are a noise. And after running through that algorithm, it can even remove that noise and give you that image. So that's how, like, it helps to one application is to remove noise because it of the trained data. Second, the last type of learning is combination of both labeled and unlabeled data. So if you have a very large set, and if it's very a time consuming task to label those millions or thousands of data, what you can do is maybe you can label a particular set and let the other half or other part of the data be unlabeled. Now we'll talk about CNN, which is convolutional neural network. And as I mentioned earlier, that generally this type of hidden layer network is used when we are working with images. So why CNN? It has a network with filters in in it, and using those filters we can determine various patterns like edges, shape, textures, curves, colors, and it also keeps tracks of the relationship between those uh, filters. So as you can see, is a good example. You did when you are composing that neural network with convolutional layer, you you determine or you give input of what are the number of filters you want in that network, and the network will randomly generate those filters and try to identify patterns from it. Mm, yeah, a good example is like, let's say you have this as an input, then the machine generates this this kind of four random filters, and in the output, as you can see, like this has a bit of horizontal pattern, and it highlights those edges over in this part, and you can keep track that how different edges are determined through these filters. And it grows bigger and bigger as you progress through the network. So in the start, it can be just edges. Then later, it will try to determine if it's, let's say, it's training on human faces. First, it can determine the edge, then small objects like eyes or ears or nose. Then in the later layers, it can even determine the face. So progressively, it will determine larger objects and the relationship from it throughout when it goes through the network. So this is, yeah, yeah. So there are various blocks, and these are just examples of some filters they use. So in the first block, this is how a filter looks like. In the second block, these are some filters, and there are various filters in each block. And each, what I mean by each block is the whole layer in that block. So these are multiple filters in the block mentioned here. And as you can see here, it's able to determine the shape. All right. What is latent space? So once you determine the geometry or shape, I think I should have an image. Ultimately, with each uh, layer pass, you're compressing the data, and through that information, you can plot the whole train data into a space which is very high dimensional, containing all the feature values. So as you can see in this image, you will find that the ones with 7 are a bit near to 1. So depending on how the machine identifies those shapes, it will cluster those forms in this space, in which like you can determine the similar data points. And one way, one other example which may be good, let's say uh, you have in this area a, a face of a man with beard, and in this area there would be a face of a man without beard, and it's clustered with all the faces without beard and with beard. So if you have a vector and interpolate between these clusters, you may see a gradual, like an increase in terms of zero beard hair to full beard. So that's how like this clustering in this latent space can help you to play with different features the algorithm has identified. It can be even possible that there are clusters with there is no smile and clusters with smile, so you can interpolate between those values. And you can find like the whole concept in detail in this link as well. Let's wait. I'll pace up a bit. All right, so now we will go deeper into the algorithms which uh, we experimented yesterday. So just to recap, what style transfer does is you take a content image, you give an input of the style image, and then the output is the stylized image with the style features extracted from this image and the content from your input image. And I think now you may be able to relate this diagram better. As I said earlier about the convolutional neural network, as you go deeper, uh, let's say the first block will identify edges, then the next block will identify various shapes and later features. So you may think that maybe from the content image, when it's decomposing the input image, it's just taking the edges from this network instead of the whole features. So let me annotate. So from content image, if I just take edge, then in the final image, I can retain the edges of content. I think it would be more clear once I go into the paper. Right, let's sorry. So this is the collab script which we worked on yesterday, and it has this GitHub link which is the same. You can see, first of all, these are the information of the papers. We will discuss it now. So the way I approach working with different model is, first I will quickly read the readme file of the repo. Then I'll be able to understand what are the different parameters I need to uh, manipulate in my collab script, and what are the different possibilities. All right, so this is important. So yesterday we did is just this basic command where we had an input of content image and style image, and we ran the command. That's it. So this is just if you want to operate the script with very less operations manipulation. This is all you need to know, that in order to run this model, these are the types of input you need require. Then if you want to investigate more, that oh, I got this stylized image but I want to manipulate with the iteration or the amount of style image and content image, then you will go deeper into what are the arguments in this script. And so these are just the two basic arguments we provided at the beginning, but now you can play or manipulate and experiment more with this additional arguments depending on your need. So conventional stylized image has, let's say, 524 uh, pixel output, but if you want a bigger size, then you can give an input up to maximum 1000 pixels. If you want to do a higher iterations, and you can also vary the value of this variable. So this is the second level where first you know the basic minimum input you require to run the model. Second step is what are the arguments you can manipulate so that you understand the model better, or if you want a specific outcome from your collab, then how you can manipulate the arguments for your need. And this also explains the requirement for each arguments. The next thing I do is, once I know the argument and I manipulate, if I want to go deeper into, oh, what are the implications and what did the researchers did in their experiment, then I'll scan through the paper first. And it's a good practice to go through the paper, and even if you don't understand few concepts, but you get a really good idea about what are the problems, what was the driving parameter for this research. All right, now it might make more sense for you to understand the CNN. So this is the convolutional layer neural network, and as I mentioned earlier, there are various filters in each block. I think I'll annotate. One thing to notice is, with each run, uh, the size is getting compressed, and you can see the resolution is getting low. And from my understanding, this initial uh, blocks, which has a determination of edges and curves, will give information about the finer detail of your input. And in the later part, this will give you information of the bigger uh, shape or object data. In this network, apart from CNN, they added style representations. Uh, One second. Yeah. And you can see these are different convolutional layer. It's 1, 2, 3, 4. Yeah, this is an important image. So these are different layers. And in this experiment, they extracted information from layer 4. For this is our input content image. This is our stylized image. So from this layer, they extracted information, and I believe it's about the edges that they paired up with the stylized content from this convolutional layer network. And this is the uh, equation for the loss function. I won't go deeper into that part. Yeah. Okay. Uh, Now, as you can see in this comparison, if you manipulate the ratio alpha by beta, if it's 10 is to minus 4, the stylized image has predominant character of style content. And if you increase the value, let's say 10 is to 3, 10 is to 2, and 10 is to, it's getting more in content from our original content image. So this is content image dominated output. This is stylized style image dominated output. So as you can see, if you want, depending on your intent, if you want like more stylist style character, you can have higher value. If you want more retention of content image, you can have a value around this part. Yeah. In this image, you can see that as per the algorithm, they extracted the value from convolutional layer 4, and you can even extract a value from convolutional layer 2. But as you can see, if they extracted that, it pretty much retains uh, the the structure of the original uh, content image, and the finer details are retained as it is. But in if you take from convolutional layer 4, it also modifies, and these are not straight anymore, and it responds to the stylized image. So depending on which convolutional layer the data you are extracting. So in this block, we are importing TensorFlow. Sorry. And here we are cloning the whole uh, GitHub repo. And I should also put how. So once you know the requirements and README file, this operates on this neural style Python file. We double click, you can see what are the arguments in this file, what are the libraries it's importing. So what ultimately we are doing in Collab is later we are running this neural style Python file, which is this. We are giving it a value of those arguments, this too. And then it will perform different functions in which are mentioned in this Python file. So it it gets the weights from, I think, yeah, VGG19 convolutional neural network. So it extracts the weight from that model, and these are some uh, convol layer which they're operating the weights on. And if you go through this, you will get an idea about how the whole model is working, where it's getting weight from. Mm, yeah, this is the loss function definition. You can even do it for videos. I didn't talk about it, but there's very good um, instructions, and it's also they have also included the paper, so you can even perform your style transfer operations on video. And this is an example, right? So mainly it's using this neural network style Python, and also this file where it's extracting data from the folder. If you remember, we were uploading the files in this image slash input folder and stylized style image in this style folder, and the algorithm ran and it created an output folder where the style transform was working. So basically, yeah, if I bluntly say it, the way some most of the algorithms which I have worked function is you import library, you import the code from either GitHub or other platforms. And once you have all the code blocks and files ready, you give them the arguments, and then it will start running. And it depends on also what type of ML model you're working on. If you need to train the data, there's like a training part involved, a testing part involved, and final required output code block. Okay, now I think we will move on to style transfer. Again, yeah. So uh, a quick recap from yesterday. GAN has a generator and a discriminator, so both neural network are fighting against each other to fool and create realistic images. Today I want to show like how the training is done, and so for StyleGAN, step one is to generate dataset, and I would I would suggest there are many YouTube tutorials or even GitHub files where they have shared the procedure of data scraping or image scraping from Google, Pinterest, Instagram, Flickr. So using those uh, files or like code, you can generate your own dataset. The next step you will do is training that dataset. So as usual, you load the TensorFlow model, you import the drive. We are importing because I have uploaded all my dataset in my Google Drive folder. Then we uh, clone the StyleGAN2 files from this link, and this is the pickle file. Right now, I won't discuss in detail, but it's important to know the concept of transfer learning. So sometimes, let's say there's already a StyleGAN data trained on human faces, but if you want to make a StyleGAN on, let's say, buildings, instead of starting from scratch, you can build upon the training data which was trained on human faces. And first of all, like it was a surprise to me that whoa, how that works. But if you recall from the convolutional layer, it's generating random filters and it's training the model accordingly. So because of those random generation of filter, it is applicable to even buildings where it can determine the edges and it can continue and build upon that information. Maybe a very vague analogy is like if I know a particular language, it might be easier for me to learn a new language compared to starting from scratch. And if I don't know any language, that's why you can use a train model. Generally, the format is pickle file if it's uh, using TensorFlow. If it's using PyTorch, it's PT. Yeah. So this is how I give the instruction to my model that this is a train model location, and as similar to neural transfer, we run a Python file where this is the main py file. These are our arguments where I'm giving an input of my dataset directory and the dataset. So once the model knows the location of those two, it will start the training, and these are some arguments. So for the temple data I shared, I did around 20 hours of training, but generally like it's preferable to do more training. And that's how, remember the two files I asked you to upload on your drive. One was the pickle file, which was generated once I performed a 20 hours of training in this code block. And then you can do projection with it. Uh, you can see how the model is learning from facial data to your uh, assigned style data. So that was one part which was of which was one input file I shared yesterday. The next was the npz file, and I'll quickly run through how I created that. And first of all, the two scripts which I shared you yesterday are originally created by Derek Schultz, and I modified a bit so that we can perform experiment for this webinar. I just want to uh, clarify. So in GAN space, first, one thing we need to know is GAN space is written in PyTorch and not TensorFlow. So the first exercise we need to do is convert the pkl file into pt file. So that's why the code blocks above are mounting that. This is cloning the GitHub directory for GAN space. Yeah, a few installation of packages required to perform this exercise. So once we load that, then this code converts your pickle file to pt file. And as mentioned earlier, we require that format because the GAN space code was written to operate on .pt file format. Then we run this PC analysis where you need to add one variable and the resolution you want. And this is the link which you need to update with your PT file, which is the output you received from this. And then this performs the analysis, PC analysis. And these are the two Python files which it operates on. You can see the different convolutional layer. Yeah, and now, after that, it generates that npz file which I shared with you later. And this part of the code, which we loaded a vector from this part, it's the same exercise we did yesterday. And you can see this UI. So to summarize, gathering data set, training your model, and if you want to manipulate in the GAN space, converting that pickle file to PT file, using that PT file, generate npz file, which is the latent space and GAN space information. And after you have generated that uh, feature vector information in GAN space, you are just extracting each vector, which are like the name of the component. And using this, you are like manipulating the value in that vector space. Right. I'll quickly run through the StyleGAN code. Yeah. So if you remember, the training part was operating on this dataset tool Python file. And I think Uh, so remember the three level which which will help you to operate if you are working on a data model from scratch. This is the minimum information you require to work on your Collab file. You just provide input for this arguments and you're good to go. Then you can start running. Then if you want to know more information about the arguments, then these are various arguments which you can manipulate depending on your system requirements. If you want to mirror, augment data, change the resolution, and other parameters. That was second step. And the next step is to go through the paper. I think this is StyleGAN 2 paper which they improved upon the StyleGAN 1 version, and it's pretty recent. So the exercise we did, this is StyleGAN 1 paper. Yeah, actually, it builds upon the style transfer. Yeah, so this is using unsupervised learning algorithm. It gets high level attributes like pose, identity, and use a stochastic variation, like using that random uh, the generative part of the GAN. It plays around with the finer details like freckles hair and develops intuitive skill specific synthesis. Yeah, few things. Yeah. So how does style mixing is it collects two vector in the latent space. As you can say, this is like one vector and this is another vector. And depending on uh, the resolution which we are dealing with, so if you remember the finer part which was earlier in the CNN network, this retains like the finer image from this source, and it's just manipulating the hair part. And if you see the cursor, this is predominantly keeping this part and just changing the finer images from source B. This has more information from source B and like a middle ground information from source A. So depending on like the resolutions we are dealing, we can see which vector is having more uh, dominance. Yeah, these are the finer details of stochastic. It's 829. Okay. All right. Next is what are some good resources if which can help you for artistic uh, explorations and development. Uh, I would highly recommend this course, which is machine learning for artists. And the name is Neural Aesthetic, and it goes into each aspect in very much detail. Yeah, they even have the link of scripts for exercises, which you can work upon after you learn the concept. And it's also on YouTube, yeah, all the video lectures. So this is one good resource. And another is artificial images. They even have classes if you are if you want to enroll. And a lot of the videos discussed in those classes are uploaded on YouTube. So you can even find information on, and it's run by Derek, whose script we manipulated on. He has also has like quite detailed videos on training for StyleGAN, also data scraping and image scraping from different websites. So you can definitely follow his YouTube channel. Yeah. So what I would recommend is sometimes depending on the problem, let's say you want to make your own collab script or work on a collab script of CycleGAN. So if you sorry, you search, sometimes you don't need to code from scratch, and there are like readily available Collab scripts which you can manipulate on. And there are also instructions listed. You can even go to GitHub directory. You can find information about the paper they have used, what are the arguments you need to manipulate. Yeah. So the way pix to pix work is like you pair up the data set. Oh, sorry, this is StyleGAN. Yeah. So you give input of all the zebra and another input of all the horses, and the machine trains on the whole network. And then when in your after the training is done for your new test data, it will convert the horse images into zebra because of the training. So there are very really good applications of StyleGAN, pix to pix. You can even make a develop where you give two paired images. One is of the sketch you do on right side and the rendered output on, as you can see, on left and right. And once the model is trained for your new test data, you can just do a sketch and it will automatically generate a rendered image because you have trained all the model based on your outline sketch and what kind of output you expect. So there are pretty good applications, and even you can they have listed collab scripts for that. Yeah, I think now I want to mm, maybe answer some questions we have. So I'm the one part the one philosophy which I am following to learn machine learning applications is what are some areas where I can focus on. Like I'm developing applications related to architecture. I'm exploring scripts and algorithms where I can extract the artistic style from those algorithms, and I focus on learning those theory part. I'm I'm still developing knowledge, I would say. So if I'm unable to answer few of your questions, definitely reach out to me. I'll try my best to get back to you after my explorations. Yeah, so I'll share the PPT link and it has all the links which I discussed today. Ashik, I should you can follow this link. And Siddhartha, can you elaborate on your question? What is a good place to get research on DNN? So one way is you can read papers on DNN. You can find uh, the GitHub repo which people might have already developed related to DNN. So that is a good place to start. Oh, that's a good question. I should some experience in MLN sounds. Yeah, actually, because of the time limitation, I couldn't cover, but I really wanted to share an audio reactive. I'll share the link. Uh, Let me share my screen. Yeah, if you this is the person I was talking about, artificial images, and He even list the slides for his presentation. And I would suggest you to check this audio reaction part. Uh, Maybe I can quickly, where he trains again and pairs up with the audio part. Let me see. Where's the output? Yeah. If you follow this script, you will be able to manipulate with audio and GAN. Yeah, I will share this link. So Gizm, I shared the PPT to link. Yeah, so I'm sharing my email ID in case you have any questions. Yeah, yeah, yeah. If like, thanks a lot, Mr. Datta. Yeah, I would like to discuss the architecture applications with you later. Uh, you have a few questions you would be happy to present at the end. We have few minutes, so yeah. Can you elaborate on what kind of questions you have? I think I'm addressing to Mr. K. Datta if they they are available. All right. Okay. All right. Are there any other questions? This is a good place to find research on ML for music and NLP works. Yeah. I think for research papers related to AI, this website is really good. You can keep track of the development. Yeah, it would be great if you can share your output on social media, even with the hashtag, and other people can keep track and can also look at your work and learn from it. Are there any questions related to technical side or artistic side? Any feedback which you would like to share? And this is my first webinar, so yeah, I'll definitely improve upon it based on your feedback. All right. So if I'm not receiving any questions, I will share a couple of GitHub repo which would be really useful for you. One is this ML4A. Next is If you want to experiment uh, for related to artistic style with a ready-made collab script, just this is a really good collection. And it also has audio reactive, which I think should you want to experiment on. So there are scripts here. What else can be useful? Yeah, I think we already crossed 1 hour, so I won't stretch.
Guys, please remember to fill the feedback form after we're done with this. Mayur, thank you so much for conducting this webinar. I hope everyone had like great takeaways from this and gained a lot of information. And we hope you enjoyed this webinar. It was great having you here, Mayur. Kirti will just briefly outline the feedback procedure and then we'll end this session. Thank you very much.
I also want to thank the organizers and the participants for uh, being part of this webinar. I appreciate your presence. Kirti, I think you are on mute if you're saying.
Yeah, just a second. Okay, guys, just a small reminder. So please go to our website www.teamshunya.com and click on the feedback. It will direct you to a form. Please fill it. So this is just a feedback form so that we can improve it the next time.
All right. Okay. Have fun exploring artistic applications related to AI models. I hope uh, you had a good time. All right. Bye.
Guys, please do fill the form to receive your certificates. Thank you so much, sir.